this video, we talk about exception handling. There are many ways to handle errors. You know, the title of the lesson is error handling, but we feel that exception handling is basically the way to go. So that's how we're going to teach this, and it's how we'll do it. And we're going to do the very simple version of exception handling. So we're not going to get too bogged down in a whole bunch of different ways that Python can do it. The idea is that you understand what error handling is / exception handling, and that you're able to use it when you need to in your programs. So let's just go through a try except flow of control. So that's what I want to talk about just for a few minutes. And you can see I got it written here. You can stop the video and read what this thing says, but it's a pretty straightforward thing. The first thing it's going to do is it's going to get into the try code, or the try suite, I should say, the try suite of code, the code that's written in this try block. And if an error occurs, then it's going to stop. So it'll start executing lines of code in here, and the second that it hits an error, it's going to stop. It's going to abandon the rest of the code that's in the try suite. And then it's going to raise the exception for that particular exception. For example, if you tried to index through a list that was that was one that wasn't in that list, then it's going to give you an index error. And we'll see an example of a couple of these here in a few minutes, and we'll see an example of this whole sort of flow here in a second as well. So if it doesn't, so it's going to look for, so if there's an index error, then it's going to look for the except index, because I could write a couple different blocks here, except suites. Yeah, I think the correct row is an exception suite. So this should probably say exception suite. But you could write a couple different ones. You could have one for index error, one for name error, one for division by zero error. I mean, there's a lot of these that you could have in here. But this one, this just except, is the general sort of generic exception suite. So what it is, if it doesn't see an index error somewhere in here, then it'll just search out and get the generic exception suite. And so then after the errors occurred, it abandons the code, then it rolls into the exception suite that it corresponds to, and then it'll start executing that code. And then when it's done, it'll jump out and start executing the rest of your program. If no error arises, that's number 6 down here, then it'll just never do any of these except statements. So it'll just do the code that's inside the try suite. All right, with that being said, let's go ahead and jump over to Spyder, and let's just get a couple examples. So I'm just going to write it in. So int 2.1 F9, and you see a value error. So we'll come back to that here in a few minutes. So what it's trying to tell you is I can't convert 2.1 to an integer. It doesn't make any sense to me. How about 2.1 divided by 0? You see a 0 division error. A is equal to 1, 2, 3, and then I try to go in here and get A3. So let me go F9. Oops, I pressed F10, I think. So F9, we see index error. So this piece in red here is the exception that was raised, and then it just gives you some sort of print out to the screen that lets you know what's going on there, or at least what they think might be the problem. Okay, let's try. So let's do a try except. So here's my try. So I'm going to print, just to show you that it does execute, comma A1. Sorry, so we'll actually print some stuff out. That should work. And C is equal to B. Should not work, right? So we should get an error there. A3 we already know doesn't work. Int 2.1 we know doesn't work, and 2.1 divided by 0 doesn't work. All right, so we know none of these work, except. So my exception statement is just going to do, in this case, I'm just going to say print other. Right, so if you're going to run this, you got to run the entire sort of block here in F9, and you can see what it does, right? So it comes here, it prints, it does this, it prints here, and then a 2 underneath it, and then it goes and it says, all right, I have a problem with this statement, right? If you read it, it says undefined name B, so it kind of gives you an idea of what's going to happen here. But then it does the generic except clause here. All right, let's give another exception. So remember, I said we can do a couple of these. So except, what was that one again? it was other, oh, it was name error. So we'll do name error. It'll be a name error, and what are we going to say? Something to the effect of your variables, your variable must be defined. So something to the user to tell them that they got to do something different. All right, so it's going to get here. It's going to say, all right, it's going to print that sucker to the screen just like it did already, and then it's going to get here, and it's not going to execute any of this other code, and it's going to tell you, oh, hopefully it goes into this one because that's a name error. I believe that's a name error. Yeah, we'll see. We'll see what happens. F9, and it says your variable must be defined, and it did not execute this other one. So notice that so it went in instead of doing this generic one, it found the exception that was raised because of this error here and executed that code. And that's key. Now it's going to go through and it's going to have this index error, and guess what? It's not going to execute the name error because that's not a name exception. So hopefully. Other, right? So it's doing other. Now if we want to tell the user you got to do something besides other, I think this is index error. Yes. And print. Let's see. Index error. Your index is out of. Your index is out of range or something like that. Do that. All right. So let's find out what happens now. All right, so because this was an index error, it doesn't do this one, but it finds the index error and executes that. So hopefully this is making sense to you. Again, if we did this one, we get other again because this is called a, was it a name? I forget what they called it. Let's see. Let's go back up. Type error probably. There we go. Here, matter of fact, I can just execute it again, F9. It's a value error, right? So I could come in here and say accept value error print string. Let's say string must be an integer. Do what we did last time and say, well, if that's a value error, then do this float. So if this were some variable that went in here and it wasn't defined, we would pass that float out 2.1. How about that? Yeah, let's do that instead. I like that better. So instead of trying to int 2, we're going to float 2 like we did in our code last class. Oh, I forgot to print it. So yes, it can do that, and it doesn't really do anything. All right, try it again. 2.1. Okay, so it actually did what we expected it to do. Okay, well that's it. That's not the end of the video, but that's all I wanted to show you. That's really all I wanted you to be able to do for the exception handling, is basically figure out, okay, if there's an error in here, then it's going to come out, and this is the simplest case where you just have an accept and a try, but then you can give the user other error messages if you want. The next thing I want to do is I want to come up with this function. So so x can be a vector, or a list, I should say, in Python. So x squared plus x1 squared plus x2 squared plus dot 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 plus xn squared. So this is a bool, a multi-dimensional function that describes some function that we know the minimum. I know the minimum of this one, right? So it's just the square root of every single term, like the square of the distance from any point to the zero basically. That's what we're talking about. So I want to define this function, right? So I could say f is equal to, if you remember lambda functions, lambda x, and then you could simply just say, we could do a sum of, now I got to go into this thing and say x sub I. So we're going to create this list using list comprehension, and I'm going to sum it. So that's xi for I in range length of x, right? So that's what we have to do in order to F9, and this should work for any dimension, right? So if I do 1 and 2, we get a 5. If I do a 44, I get a larger number, and we can just keep on putting in dimensions, and it keeps on sort of going on, keeps going on. And so that's what we would expect. Here, let me put a number that we can actually, in our head, do. So 16 plus 4 plus 4, 8, 16 and 8, 24 plus 1 is 25. Okay, so all that's making sense. The problem with this one is, what happens when I put F1 in? So we get this weird error. And I have a problem with that. Oh, oops. I was just going to use that one. So I have a problem with just putting in F1 and not getting something for it, because I want my function to be good regardless of whether I put a list in or whether I put just a single number. So what we'll do is we'll define this new function called f of x. And then we'll, I amuse myself sometimes. So all we're going to do is try to do exactly this. Let's see, so we'll try and we'll return this thing. Work. Then what will we do? Except that doesn't work. I want to return, oops, if I could spell, I want to return that squared. Okay, so hopefully when we, not F5, F9, okay, so we got F9 and then F of 1, 2, 4, 2. Oops, that is wrong. It needs to be a list. In that case, we're passing in one. We're always passing in one thing, whether it's a container, a list, or whether it's just a particular number. But you can't pass in several numbers, right? So that should be 25, and that'll work. And then F of 1 should also work, or F of 4 should also work. Okay, so that's pretty much what I wanted to do with this try except here, right? So you can see the power of it. You know, before, and we could have done it with the lambda function as well. It just would be a lot of code in one line, and I didn't want to do that. I think this is better for readability purposes. All right, that's all I got for this lesson. Be aware that we're going to use this in the future, right? So the end of this lesson, we're going to go to a gradient descent algorithm. So we're going to develop that together, starting next class with calculating the gradient in a most general case.